Hello, this is Mr. Collier, and today we're looking at the intersection of three planes. Okay, so these are the different possibilities. You could have them all parallel to each other. Then, of course, there's no solution because they don't intersect at all. This is no solution. Here, you got the two of them are parallel, and the other one intersects with the other two, but there's no place where all three of them intersect. So there's still no solution to the intersection of the three planes, right? Here there's a unique solution because they all intersect at one point, so we call it a unique solution. And here, this is also a case of no solution. They intersect at three different lines, but there's no place where all three of them intersect at the same spot. Here we have they intersect at one line, so this is an infinite number of solutions. Every point on that line is a solution. So infinite number of solutions. Okay, we call these parts where we get a solution, we call it a consistent system, or the equations that we use are called an consistent system, and this is called an inconsistent. So this is also consistent, sorry, because we have a solution. Oops. Consistent. And then when we have no solution, it's called inconsistent. So sometimes that inconsistent. Sometimes that terminology is used. Okay, so let's take a look at some examples. We've got the equations of three planes right here. To solve, just like with two equations, we got a little bit more work. We got to try to get some variables to cancel. So we can add the first two equations together, or we can add the first and the last, and the z's will cancel. Let's do that first. So we add those together, we get 3x plus 2y equals 8. And now let's do x minus what's the second one. Now we need to use the second one because we used the other two. Okay, and I'm going to take the last one and multiply by 2, and we get 4x plus 2y minus 2z equals 2, and then we can add these together and the z's will cancel. 5x plus y equals 11, and I'm going to bring that over here, so 5x, actually I'm going to bring it over here and multiply by 2, so 10x plus 2y equals 22. Subtract these equations, we get, I'm going to subtract this way, 7x equals 14, x equals 2. Okay, so we've got x equals 2. That means actually that they're going to intersect in a point, and we just need to plug in this x value to get the y and the z now. So I can probably plug it in right here. 5 times 2 plus y equals 11, so solve that, you get y equals 1. And then we can use any old equation here. The first one looks pretty easy. 2 plus 1 plus z equals 7, so z equals 4. So they intersect at the point 2, 1, 4. Okay, next, so sometimes we'll look at what happens now when we have intersections line. So we can do the same thing. We can try to eliminate them. And we call them equation 1, 2, and 3, and do 1 plus 2. Equation 1 plus 2 is 2y plus 4z equals 7. And if I do 3 minus 2, I get 2y plus 4z equals 7. You get the same thing. So when that happens, you subtract, you get 0 equals 0. This means, now if this is true, you have an infinite number of solutions, so they intersect at a line. If it's not true, then you have no solutions. So this means infinite number of solutions. Graphically, they intersect at a line. Okay, so we want to find that line. We can, the intersection is going to be, the direction vector of the intersection is going to be perpendicular to the normals of all three lines. So we can get the direction vector of the line by doing the cross product of two of these normals. So I'm going to take this normal, cross product with this one right here, negative 2, 1, 3. Okay, so if I do that, you get 2, negative 8, 4. Now when you're getting some random normal, you can get a scalar multiple of that. So I'm going to make my normal be 1, negative 4, 2, just to make it a bit simpler. Okay, so that's what I'm going to use for my normal. And now somewhere along this line, the z value is going to be equal to 0. So I'm going to plug in z equals 0 and find the x and the y values to get the initial point. Okay, so I can do plug in z equals 0 and I get 2x plus y equals 2 from the second equation. Negative 2x plus y equals 5 from the first equation. I can add those and the x's will cancel. 2y equals 7. So y equals 7 over 2. Substitute that back into the first one. 2x plus 7 over 2 equals 2. Solve that, you get x equals negative 3/4. So the equation of the point of intersection is the initial point, negative 3/4, 7 over 2, 0, plus lambda times the direction, or I shouldn't have called this n right here. That's actually the direction vector of the line, so that's d equals 1, negative 4, 2. Okay, so next, yeah, so like I said before, if at the end you get something that's not true, there's going to be no solution. So sometimes we have questions like this where we're going to find the k value such that there's an infinite number of solutions or no solution. Okay. So find the value of k such that there's not a unique solution. So we do the same thing as before. We want to eliminate x's and y's and try to solve for what x is, right? So we can do maybe, let's get rid of the z's first. Okay, so we can multiply 2 by the first equation, we get 4x plus 2y plus 2z equals 8. Now your second one is 3x minus y plus 2z equals 5. And now the z's are matching up, so we can subtract and get x plus 3y equals 3. Okay. So we've got that, and now we need to cancel the z's with this last one. So we could simply add these together. We'll add equation 1 and 3, and what we get is k plus 2x plus 4y equals 6. Now I got a 4y here and a 3y here. We want those to match so we can cancel them out. So I'm going to multiply this by 4 and this one by 3 to get a common 12. So 4x plus 12y equals 12. And multiply this by 3, I'm going to get 3k plus 6x plus 12y equals 18. We will subtract to get the y's again, so I'm going to subtract this way. And this minus 4 gives you 3k plus 2, x equals 30. Now, so what's the question I was saying again? Find the value of k such a system does not have a unique solution. So if k is something like 0, for instance, you get 2x equals 30, you get x equals 15, so there is a point of intersection. So most of the time you'll have a unique solution. The only time you don't have a unique solution is when 3k plus 2 equals 0. Then you get 0 equals 30. That means there's no solution. Okay, so k equals negative 2/3. Therefore, no solution. Okay, no solution when k equals negative 2/3. Okay, you can do the same thing in the next one, or similar. Now the k is over here. It says find k such that the following system is consistent. Okay, so consistent means a unique solution like a point, or intersection is a line. It says find this value of k. For this value of k, find all the solutions. So I'm guessing it's going to be a line when we find the solution, right? So if we want to start canceling variables, we can do 1 plus 2 right away. It cancels the y. Okay, we do 1 plus 2, we get 5x plus 5z equals 9. Then I'm going to then we got to use maybe 3 and 2. We can get the y's to cancel if I multiply this one by 3. So I'm going to write down equation 3. Equation 3 is negative 4x plus 3y minus z equals k. Then I'm going to do a 3 times equation 2. Gives you 9x minus 3y plus 6z equals 15. Then I add these together. I get 5x plus 5z equals k plus 15. Okay, so now I got these two equations with x and z. I'm going to bring that down here. 5x plus 5z equals 9. So if I subtract, I get 0 on the left-hand side, and I get k plus 6 over here. So now let's break down. If k equals negative 6, then we get 0 equals 0, infinite number of solutions. So they meet at a line, right? Okay, if k does not equal negative 6, then we get no solution, right? Because we get 0 equals some number, so it's going to be nonsense, so no solution. Or we could say consistent and inconsistent, I guess, if you want to be consistent with the language. So if you want to find a line of intersection, actually it doesn't ask, oh, it does ask you to do that, yeah. So we're going to find the line of intersection, then we can do the cross product 2, 1, 3, cross 3, negative 1, 2. That equals 5, 5, negative 5. So if you want the direction vector of the line, you can use that or any scalar multiple of that. So easier would be 1, 1, negative 1. Okay, somewhere on this line, the z value is going to be equal to 0. So I'll plug in z equals 0 and z equals 0. Now we can actually look back at one of these equations that we've solved for already. So I plug in z equals 0 here, we get 5x equals 9, so x equals 9 over 5. Okay, so then I can get the y value using probably just this first equation right here is the easiest one. So 2 times 9 fifths plus y equals 4. 18 plus 5 y equals 20. If I multiply everything by 5, 5y equals 2, y equals 2 fifths. Okay, so the equation is going to be, the equation of the line of intersection is r equals 9 fifths, 2 fifths, 0, plus t or lambda, whatever you want, 1, 1, negative 1.